An important category of unsupervised learning is a section of useful machine learning systems known as recommendation systems. Recommendation systems are very popular in today's world in several domains, whether it is in e-commerce or whether it is in movies or whether it is in online products, online services, etc., etc. The basic idea of recommendation systems is to look at historical knowledge of either people's likings, people's ratings, people's comments, blog ratings, etc. for different products and services like movies or for different e-commerce products, etc. And using that to provide opportunities for marketplaces like Amazon or Netflix or Flipkart to offer products in form of upsell or cross-sell to people who are already buying things online. So in terms of the basic idea of recommendation systems, the idea is you will use history of purchase or history of transactions of service or product by same consumer or across several consumers. We look at data like what are the ratings for the different products or services given by users. We look at text reviews, or we look at friend networks in terms of what is the social network of the particular person of interest is interested in, etc. So recommendation systems use all of these as inputs, or even things like a transaction behavior. Like if you look at Netflix, it captures minute by minute of how people are viewing movies, what part they are stopping, what part they are browsing fast, what part they are going through, what kind of thing they check out before clicking on a movie for paid purchase, etc. So there are several internal. There is clickstream analysis, which is basically all the parts of the data which is clicked by users before we get into the actual buying. So all of this is used as input and used by companies like Netflix, Amazon, Flipkart, etc. for providing something known as recommendations for users, either upsell, cross-sell, or sometimes offer group sell discounts, or offer customized bundles of offers, etc. in terms of business offerings which recommendation systems are made use of. So normally what people use is a set of techniques which are more in the domain of unsupervised learning. So one very simple thing which people can look at is using something like a priori and market basket analysis to actually look at what people are buying things together and to bundle that thing together. So for example, when you buy on Amazon, you always see, people who have bought this have also bought this book along with that. So that's a typical example of a priori. But what happens in a priori is it is simple dumb use of the transaction data. There is no potential usage for ratings or no potential usage of friend networks or any particular characteristics of the items that are being used in this thing. So in that sense, we have to expand the scope for technology for building recommendation systems beyond conventional market basket analysis. That's where we have a very strong set of emerging techniques appearing on the horizon, and the most important of them are what is known as collaborative filtering algorithms. So collaborative filtering algorithms are basically a set of algorithms which take into account kind of behavior of either your friend networks if you're a customer, or if you're buying a certain item, what are the characteristics of the item which is going to govern how you're going to be upsold or cross-sold. So if you see, there are two broad ways in which it is looked at. One is what is known as user-based collaborative filtering. Another is what is known as item-based collaborative filtering. If you look at user-based collaborative filtering, the idea is very simple. The idea is a user or a potential customer will behave most like his close friends. So, the tastes of a user or a customer is dependent upon what his friends or close friends in his network they like. So, it is not again governed by anything related to the item, the movie or the book being purchased. It's only related to what is the likings of his friends. On the other hand, item based is based on the idea of what are the characteristics of the item being purchased or sold. And depending upon the commonality of the characteristics, the most similar item to the same item is best candidate for sale. So, in item based, we are only looking at characteristics of the item being sold, whether it's a movie, or a book, or a particular digital item we're purchasing. It's not related to who is buying, but instead only dependent on the characteristics of the item. In some cases, we may use a hybrid approach, where we look at combinations of what you are buying plus your friends are buying and what characteristics of the items are. So in general, most of the collaborative filtering algorithms are either based on user-based or the based on item-based. Let's look at an example of user-based. Suppose there is an item 1, item 2, item 3, item 4. There are 4 movies. Assume they are movies. And then suppose there are 3 friends of A. He has seen this movie. Now, the point which we want to mention is now we want to find out what the next movie you should see. Then, if you see from the raw data of his friends having watched the movies, let us assume that we have this configuration where the movie I2 has been seen by B and D of among his friends. Item I3 or movie 3 has been seen only by C, and movie 4 has only been seen by D. So going by this user-based collaborative filtering, assuming that B, C and D are the close friends of A, after having seen A, we look at potentially recommending movie I2 to A because among the movies, majority of his friends are liking or have seen I2, and that is most likely a candidate movie for recommendation to A. So this is basically a simplest version of user-based collaborative filtering. There will be more complex scenarios depending upon notions of how to measure close friends based on either their distance measures, etc., etc. But this is a very simplistic view of user-based collaborative filtering. On the other hand, let us say we're talking about a user A. You look at movie 1, movie 2, movie 3, movie 4, and you look at characteristics of the movie, like it's animated, or it has a top superstar like Amitabh Bachchan, or then it is suppose available in multiple languages. Then you see that I have liked, suppose the movie M1 I have seen, and then I will see that it is an animated movie and it's also available in multiple languages. Now, among the movies M2 and M3, we try to find out the movie which is closest in terms of characteristics to M1. Let's assume that M3 is of the type like this, and M2 is like this, and M4 is like this, where movie 3 is animated and also available in multilingual, just like M1. M2 is available only as a top hero being acting on it, or M4 is available as multilingual. So in terms of common characteristics of M1, we see that M3 is the one which is most similar to M1. So this is a candidate which is recommended to the user based on purely item characteristics. So what we've done here is we've taken a notion of item characteristics governing the likings of end users, and based on that, we found out what is the product, which is a movie in this case, which has maximum similarity to the current movie, and recommended the same to be the next candidate product, which is a movie for the target customer. So here you see that there are two orthogonal approaches. One is based on a friend network, your collaborative users with whom you collaboratively liking, or in other cases about item characteristics, which is basically depending upon how a movie is similar to another movie which you already like. So in that sense, both are two different approaches. In some cases, we actually use a hybrid approach to collaborative filtering, where you combine both, but typically we use one of these approaches in our case. So if you see at next time you shop on e-commerce site and you see recommendations in front of you, there is internally something going on there where people have given likings based on the characteristics of the movie which is being used, and they are being used to derive what is the most likely recommendation for the next film which you will like, etc.